Hello. Today I'll be explaining my AP Chemistry final project. So we chose acids and bases. This is the 8th unit of the AP Chemistry course. So yeah, let's get into it. It's going to be a visual investigation into natural acid-base indicators using red cabbage. Let's talk about acids and bases. So this is a visual investigation into natural acid-base indicators using red cabbage. As you can see, this is a pH chart. We can see that 0 is acidic and 14 is base, and the neutral is 7. So this is just a general chart. Now let's go into the introduction. Have you ever felt the sting of lemon juice on a cut or noticed how slippery soap is? These sensations come from acids and bases in our everyday lives. Let's get into it more. Let's get deeper. Acids and bases are common in everyday life. Acids have a sour taste and include things like lemon juice and vinegar. Bases are bitter and slippery, like soap and baking soda. We can use the pH scale to measure how acidic or basic something is from 0 to 14. This is the essential question. How does a chemical reaction impact the understanding, applications, and future developments in the field of chemistry? In this project, we focus on how acid-base reactions are useful and how we can see them using color indicators. By exploring natural indicators and pH reactions, this experiment shows how chemical reactions help us understand real-world chemical behaviors and develop safer, accessible testing methods. What's the background theory behind acids and bases? So acids, they have a pH less than 7. An example is lemon juice or vinegar. And the chemical reaction is HCl is broken down into H plus and Cl negative ions. What about bases? So it's pH more than 7. For example, baking soda. So an example of this chemical reaction is NaOH breaks down into Na plus and hydroxide negative. So yeah. Now let's talk about neutral. Neutral is when pH equals 7, so pure water. Nothing's added to the water, that's when the pH is going to be 7. Indicators change color depending on pH and help us identify if something is an acid or a base. So let's move into the experiment. This is the first part. Cabbage as a pH indicator. Why did we choose red cabbage? Red cabbage contains anthocyanin, a natural flavonoid pigment that changes color in response to pH. So it's an indicator. So anthocyanin acts as an acid-base indicator by reacting with H plus or OH negative ions, which alters the molecular structure and therefore the color. So why is it useful? It provides a safe, eco-friendly way to test acidity or alkalinity. It helps us visualize chemical reactions and ion concentration in real time. So let's talk about the color changes by pH level. So a pH of 1 through 3, which we considered a strong acid, would have the color red and pink. pHs of 4 through 6 are weak acids and typically have a color of purple. pH 7, which is neutral, would be violet or blue, and a pH of 8 and 10, which would be considered weak base, is green usually. And lastly, a pH of 11 through 14, which would be considered a strong base, would usually have the colors yellow and light blue. Let's talk about the real-world applications. So understanding acids and bases helps us in many areas in life. Let's talk more and let's get deeper into this. Medicine. So acid-base applications help us control stomach acids. So it's important for hospitals and doctors to understand this idea to be able to help the patient. What about cleaning? Many cleaners are basic, which gives them the properties they need to be able to clean or to do what they need to do. What about the environment? So acids and bases help us check for acid rain or soil pH, which is detrimentally important for agriculture, etc. Cooking. So vinegar and baking soda reactions, they can be considered acid and base reactions, and they can help us understand cooking more and to get the final product. So real life use. In this case, we can use cabbage juice at home to test the acidity of tap water, soil, drinks, whatever you actually wanna test. You can use hot sauce, ketchup, anything. It's a very cool experiment. So let's talk about it. So how do we perform this experiment? So you have to boil chopped red cabbage into water for 10 to 15 minutes. What does this do? This helps extract the anthocyanin-rich juice, which is our indicator. After that, we have to filter the purple solution to remove cabbage pieces and collect the anthocyanin-rich juice. We have to pour equal amounts of cabbage indicator to each cup or beaker or cup, based on how much objects or juices or whatever you want to test. After that, you have to add a few drops or spoonful of the test substance into each container. Eventually, you're gonna have to mix it gently and observe the color change. So then you can see the acid changes, because the acid and the base changes. Like the acid and base, how strong they are would be indicated from the color. So now you have to record the results to compare pH-based reactions using the color, as I said. And this image right here is an easy example for visual learners. Now let's talk about the pre-experimental analysis. So before we did the experiment, we had to come up with a hypothesis. So our hypothesis: when different substances will be added to red cabbage juice, distinct color changes will be observed. So these changes correspond to pH levels of the substance and reflect how acid-base reactions affect anthocyanin, the pigment in the cabbage. So yeah. So as you can see, this is the table. We expect lemon juice to be pink, vinegar to be red, water to be purple, baking soda to be blue or green in between, and Windex to be green. So this is based on the pH. As you can see, lemon juice has a expected pH of 3, vinegar 2, water 7, baking soda 9, and Windex 11. So let's actually move on to the next slide. But before that, you can see this picture. This is what we expect. So you can see the different colors based on the pH levels of each experimental substance. So yeah. Now post-experimental analysis. So we have a little bit of changes. Lemon juice has an actual pH approximation of 2, rather than in the other slide 3. And vinegar has approximate pH level of 3, rather than 2. And you can see the different colors. So water also has approximate pH of 6, maybe because it's not pure water. So if you use pure water, it would be 7. Baking soda has approximate pH of 8, and Windex as well. And yeah, you can see the color, observe color, and either if it's an acid base or if it's neutral. So here are the results. This is just to help you understand how we got different colors, and we can expect and approximate the pH levels of each substance using the indicator. Now, this is a chemical reaction. When acid and base is mixed, they undergo a neutralization reaction. So acid plus base turns into salt and plus water. And there's examples of strong acid, strong base, weak acid, weak base. And yeah, what causes the color change in cabbage? So as we said, anthocyanin is pH sensitive. It's a pigment, okay? And the molecule, it donates or accepts H plus ions, which changes the shape, causes it to show different wavelengths of light, producing different colors. So yeah, color is an indicator of H plus or OH negative concentration, revealing the acidity or how basic the substance is. So let's talk about the challenges and problem solving. So faint color changes with weak substance. An example, soap or diluted samples. Cloudiness from unfiltered cabbage juice affecting clarity, and also measuring inaccuracies, so uneven volumes. You have to make sure you have equal volumes of whatever, so you can have a fair experiment. How did we solve them? So for the first challenge, we did repeated trials and adjusted volume of indicator and test substance. For the second challenge, we used double filtration to remove cabbage particles for clear juice, to remove the unfiltered cloudiness. And for challenge 3, we measured liquid volumes carefully using pipettes or graduated beaker. So to conclude our experiments, what did we discover? What we learned: this project demonstrated how acid-base reactions can be identified using red cabbage as a natural pH indicator. By observing how different substances altered the color of cabbage juice, we gained a deeper understanding of how H plus and OH ions, negative ions, affect chemical environments. Why does this matter? The ability to determine acidity or basicity is important in medicine, for example, agriculture, soil pH, environmental science, and food chemistry. We also learned that chemistry does not require labs. Kitchen science can be just as good to use when understood and applied correctly, using the safety uh, protocols as well. Future ideas. Ideas for future exploration compare natural indicators like beetroot, blueberry, and turmeric with red cabbage. Use pH meters or test strips to compare against visual results for accuracy. Scientific thinking. So this experiment required us to change our method, evaluate our data, and change and adjust based on outcomes, just like real scientists. We also practiced error analysis, all within one experiment. So yeah, these are our references, and thank you for listening to our final project.
What is going on, everybody? Today we're gonna be doing an acids and bases experiment using red cabbage. Yup, red cabbage. You heard it right. The one your mom puts in salads? No, bro, not that one. Or it's that one. It's just not for eating this time. Today we're gonna be turning it into a pH indicator, which means it's gonna help us see whether everyday liquids that we're gonna be using or components are acidic, basic, or they're just neutral. All based on the color outcome. No expensive science equipment today needed, bro. No crazy lab coats. This is just all from your kitchen, and it's just a cool way to visualize chemistry without being bored. So, yep, that's it. So in here you can see that I've chopped the smaller pieces here. You don't have to be fancy, just rough cut so it boils faster. And now the reason red cabbage works is because of this thing inside. It's called anthocyanin, which makes it work as an indicator. It's like a natural pigment and it reacts to pH, so it literally changes color depending on how acidic or basic something is. By the way, you can find anthocyanins in stuff like blueberries and grapes and other fruits, purple corn too, but cabbage is more affordable and it's easy to use. It gives us a strong color as well. So just pour enough water here to cover the cabbage. Turn on the heat and let it cook and boil for around 20 minutes. And as it boils, the color from the cabbage, it leaks out into the water, and that's the anthocyanin dissolving. You see the cabbage go kind of pale and the water turns dark. We're basically making cabbage tea, but instead of drinking it, we're going to be using it for this chemistry experiment. Anyways, here's what we're testing. All of our stuff. Lemon juice, I have it lined up. Lemon juice. Vinegar, regular water. Let's go. Baking powder. We're going to be using that after though. That's just an extra bonus. And the Windex. Each of these, they have different pH, and we're going to see how the cabbage juice reacts when we pour it in. Okay. Here is our pH scale lined up. That's if it's basic, it's going to be around the higher pH. And then for the low pH, that's for acidic, more acidic. Anyways, get that out of here, throw it to the side. Here's our spoon to make sure everything is dissolved well. Okay, let's start off, boys and ladies and gentlemen. Let's start off with lemon juice. Let's go. I have an example. I had the components lined up as an example. Okay, we're going to be pouring the cabbage water into the beaker, so it's easier for us to pour. Of course, spilled a bit, but that's okay, no worries. Okay, first up, lemon juice. Let's see. Okay, move this to the sides. We can have more space to work with in these two. Okay, first up, lemon juice. Let's go. Okay, as soon as the cabbage juice hits it, we can see that, ooh, that's a reddish pinkish color. Okay, as expected, lemon juice, with its being very acidic due to its, that's a classic sign of an acid. It's gonna be a classic sign of an acid. Okay, let's make sure. Let's see. That's the acidity scale around the low pH, and yes, it's gonna be, of course, a low pH. Okay, that's around 2 to 3, I think. Yep, as expected, it's around 2 to 3. Thanks to citric acid. Let's go. Okay, get that out of the way. Let's move on with the other stuff. Here is it. We're gonna move that out of the way so we can have more space to work with the others. And next up, Windex, window cleaner. Let's go. Okay. Let's see. Has a bluish color initially, but when mixed with cabbage juice, ooh, that's a reddish color. That's nice. Okay. Very dark purple. I think it's closer to blue a bit. This is a strong base. Its pH is probably high, around 7 to 8 expected, or just 8 maybe. Let's make sure. Get our strip, dip it, and making sure. Let's see. Flick. Yep. It is closer to a faint green color. Okay. Yeah. It's definitely not neutral or acidic. It's up there with the base. Yeah, just around there. 7 to 8. It's most likely in the middle. As expected. Okay. Move that to the side. Get that out of the way. Purple color and lemon red. That's what we have so far. Okay. Third in the list. Now, vinegar. Let's see. I'm gonna pour a bit more just to make sure there's enough to react with the cabbage juice. We can get a very good color. Oh, same story. It turns red, but maybe a little more dull than the lemon, as you can see. Vinegar, it's also acidic. Let's double check the pH just to make sure. Don't want to make any guesses. Okay, let's see. Yeah, it is orange. The pH is most likely to be about 3 to 4. Let's make sure. And yes, as expected, the pH is 3 to 4. It is slightly less acidic than the lemon, the original 2 pH. And vinegar is also acidic and about a pH 3 4, as I said, thanks to acetic acid, which vinegar contains. Acetic acid, vinegar, everything else. I'm gonna just pour the remaining cabbage juice into this beaker just to make sure we have enough to pour for the water and baking powder at the end. Okay. So of the last of the main experiments, let's get water, plain water, nothing else. And cabbage juice. Okay, let's see. It's most likely going to be around the same color. Yep, as expected. Nothing happens. It stays purple, which it makes sense because water is neutral, or it's very close to a pH of 7. That's the normal for pure water. Let's mix it just to make sure. And I poured some more water just so we can be sure that that is the correct color to be displayed for us in this video. We need to double check the pH still, of course, because that's not going to really change anything. We need to double check the pH and make sure it's at the correct acidity. Let's see. Water is, yeah, there's about no color change. It's neutral. Around there. As you can see, 6. Yep, right there. 6 and closer a bit to 7. So there's no color. If your tap water turns red or green at home, yeah, you got a problem, bro. Make sure there's nothing up in that water. Okay, done with the main experiments. Let's move those to the side and we'll be back with our final and last experiment. That's everything. Now, baking powder. Our last experiment. Let's see. Okay, here's baking powder. We mixed it. Okay, yeah. Let's check that out. Those are the other experiments. Gonna be placing about 2 teaspoons just to see. Now from baking powder, we are expecting a basic solution, a color that is most likely basic. We think that it's going to be basic not only because of the color, but baking powder does not have anything that could. It is most likely just to be basic, and it's not. It doesn't have acid. It doesn't contain any acid. Like our past experiments with citric acid and acetic acid, baking powder, it is, yeah, slightly basic. On the pH of 8. Also, you notice it formed a bit of bubbles. Yeah, that's carbon dioxide. It's bubbling. It's because baking powder has both an acid and a base inside, or it's actually just a base. But when it does get wet, they react and they release gas. Same thing that makes cake rise. Anyways, that's about it. If you guys do try it yourself, tag me in the video. I want to see what color combos you get. Thanks for watching, and yep, catch you guys in the next video. Red cabbage, man, such a cool indicator. It's safe and easy to make. See you guys. Bye.